Around 13.8 billion years ago, there was complete emptiness. No people, planets, or space. Suddenly, a mysterious explosion happened, giving birth to the universe. Over time, stars, planets, and eventually Earth and humans came into existence. But this raises a curious question. Why did this explosion happen in the first place? And how did it lead to Earth, a planet with intelligent life like humans? Unless someone purposely made up this story, it remains the greatest puzzle that no one can solve. Some even believe that the universe might be a highly advanced, scientifically created simulation. Just 40 years ago, the games we played were simple and two-dimensional, like Pong. Fast forward 20 years and we got StarCraft. Now we have incredibly realistic games and immersive virtual reality experiences. Considering the universe is 13.8 billion years old, 40 years is just a tiny moment. So, what would these simulations look like in 1,000, 10,000, or even a billion years?
It would seem to follow that the odds that we're in base reality is 1 in billions.
If we think that technology will keep improving, even at 1% of the current rate, we'll eventually create virtual worlds that feel just like real life. Do you agree with this idea? If so, there's a problem. Virtual characters with fully functioning brains would think their world is real, and science and technology would keep advancing in their virtual world. At some point, technology in that world could create simulations that are just like their reality. This suggests that once we create a virtual world, another virtual world could appear within it, and another one inside that, resulting in an almost endless chain of universes. Then how can we be sure this hasn't already happened? We can't. The universe simulation theory starts here. Some scientists even think that the universe might actually be a computer. In April 2023, Stanford made an astonishing announcement. They created 25 virtual humans powered by ChatGPT and let them live freely in a virtual world. As a result, these individuals wake up at 6 a.m. like real humans, cook breakfast, and go to work. The artists paint and the authors writes. They form opinions, recognize each other, and start conversations. They plan for the next day while remembering and reflecting on the previous day. What's even more remarkable is that they interact with each other, form relationships, throw parties, and even distribute invitations. They were not individually programmed as individuals, only their basic personalities and situations were set. Yet these virtual humans act with free will. It's as if they are just like real humans. If our current understanding of physics is accurate, simulating the entire universe with its trillions of objects is impossible. However, we don't need to do that. It's enough to make the inhabitants of the simulation believe they're real. Do we need billions of galaxies? We only need the space that our subjects can actually explore. The vast universe could be a flat projection, and they would have no way of knowing. What about smaller things like cells or bacteria? We don't need them either. What we see through a microscope can be created instantly. The same goes for atoms. The chair you're sitting on doesn't need to be simulated with countless atoms. The simulation only needs its outermost layer. It could be hollow inside until you decide to break it open. Your body might feel solid, but it could be empty until you actually open it up. The minimum requirement for a simulation is the virtual human's consciousness. Our subjects only need to believe the simulation is real. So are we being simulated? When we play realistic video games, we control our characters, moving them, and exploring the world from different perspectives. It feels like we're experiencing a pre-existing world, but in reality, the game doesn't show the areas behind the character that we can't see. This is because it's more efficient for the game to avoid creating high-capacity spaces that the character doesn't observe, and only generate the objects and environment when the character sees them. Interestingly, our universe seems to work in a similar way, processing vast amounts of information efficiently. This can be illustrated by the famous double-slit experiment in quantum mechanics. This experiment aimed to find out if light is a particle or a wave. To do this, light was sent through two tiny slits, and the resulting path was observed. If light is a particle, it should go through one of the slits and create two separate paths. If it's a wave, it should create an interference pattern. However, before a camera was set up, a blurry interference pattern appeared, as if the image wasn't fully formed. When the camera was in place, only two clear paths remained, as if we were looking at a fully rendered world. This means that electrons act like particles when we see them, but like waves when we don't. Similarly, computer games accurately calculate and display objects when we observe them, but they only exist as calculations when we don't. To put this into a more relatable analogy, if nobody on Earth is looking at the sun, it disappears. But when someone looks at the sun, calculations are made, and the sun comes into existence. Our world might be operating efficiently in this way, even saving computer memory. There's intriguing evidence supporting the idea that the universe might be a simulation. It seems that the universe operates with certain limits, similar to a pre-existing program designed for efficient processing. Our world has a minimum unit, called the Planck length. The Planck length is a specific and significant minimum length in our universe, derived from a combination of constants related to the fundamental laws of physics. Moving 0.99 Planck lengths is the same as not moving at all, and moving 1.99 Planck lengths is the same as moving 1 Planck length. In other words, values smaller than 1.0 Planck length are meaningless. This is similar to the minimum units we see in data bits and pixels in graphics. Furthermore, the speed of light, as defined by Einstein's special theory of relativity, is constant at 299,792,458 meters per second, whether in a vacuum or in the air. This constant speed of light is thought to be a limitation that prevents infinite calculations in our computer. Some scientists believe that the universe is expanding because not all calculations have been completed yet. Regardless, these ideas suggest that our universe itself functions like a computer with various limits in place to maintain efficiency. A philosopher tries to examine this argument in a more practical way. In 2002, philosopher Nick Bostrom published a thought-provoking paper titled, "Are You Living in a Computer Simulation?" Nick Bostrom posits three potential scenarios. The first is that mankind might be wiped out by unavoidable catastrophes like nuclear war or pandemics before we develop the technology to create a simulation, thus failing to construct a virtual realm. The second possibility is that even with the capacity to create simulations, we might choose not to. The third is that our reality is actually a simulation. Elon Musk, on the other hand, argues that it's preferable to believe we live in a simulated reality. If our world is not a simulation, we might be marching towards extinction. It seems unlikely that our future generations, equipped with the power to build simulations, would abstain from doing so. After all, we're already operating numerous simulations. Therefore, it's arguably better to hope that we're living in a simulation. How would you respond if, upon your death, someone removed your virtual reality headset and asked, "How was your life?"